Assalamualaikum and hello everyone. My name is Siti Aisyah binti Muhammad Zaidi with metric number E20A0486 from SEJ program. The experiment that I'm gonna demonstrating in this video today is experiment 6, which is gas properties. There are 4 different experiments under this topic. I choose experiment 6C, which is explaining about Charles' law. This experiment explains that Charles' law is an experimental gas law that describes how gases tend to expand when heated. The more right statement for Charles' law is when the pressure on a sample of a dry gas is held constant, the temperature in Kelvin and the volume will be in direct proportion. Okay, before I start the experiment, I'm gonna briefing about the instrument and what all the button represented to. Okay, first of all, this is the pump that will pump in the particle into the container. The blue one is the large particle, meanwhile the red one is the small particle. Particles can be added into the container by pressing this button like this. Okay. Next, this is the thermometer to measure the temperature in the container, and this is to observe the pressure in the container. Under the container, there are a function that can be used for heating or cooling the container during the experiment. There are also a button to measure the weight of the container, like this. The stopwatch to record the time, and the collision counter to count how many particles that collide with the wall of the container. Besides, we can also choose between these 5 to hold constant according to our experiment. Next, the methodology of this experiment is first by pump in 50 large particles into the container by pressing the button like this. Then, set the pressure as the constant of this experiment. After that, set the temperature at 200 Kelvin by cooling the container like this slowly until it reaches 200 Kelvin. Do it slowly because it is quite hard to get the actual number of the temperature. Okay, after the temperature reach 200 Kelvin, measure the weight of the container. The weight of the container that we get is 6.7 nanometer and record it in the table. Next, repeat the step by using 300 Kelvin and 400 Kelvin temperature. For 300 Kelvin temperature, the weight of the container that we get is 10.0 nanometer. While for the 400 Kelvin temperature, we need to heat up the container until it reaches 400 Kelvin temperature first. After the temperature reach 400 Kelvin, the weight of the container can be measured. The weight of the container that we get is 13.3 nanometer. The result will be recorded in the table. Lastly, repeat all the steps by using 50 small particles. The result shows that the weight or the volume of the container increases as the temperature increases with the constant pressure. The increase of the temperature causes the molecules of the gas in the container have more kinetic energy. They strike the surface of the container with more forces. This causes the force on the wall of the container to increase and so the pressure. If the container can expand, then the volume increases until the pressure returns to its original value. However, there is no differences between large and small particles. It is because the size of particles does not influence the volume of the container. The conclusion that can be made is that the purpose of this experiment, which is to determine the relationship between temperature and volume, is succeed to achieve. Charles' law is a law that explains this correlation. It is stated that temperature and volume of a gas are proportional to each other. So when the temperature increases, the volume will also increase.